by Jamie, security specialist from APNIC. So I would like to hand over the session to you, Jamie.
Thank you very much.
Yes.
Let me get the microphone here. Just give me 1 second, just making one last little change on the slide. And there we go. Okay. Thank you everyone for coming back after lunch. I know it's always hard to come back right after lunch and be awake with a full stomach of very tasty food. So thank you for being here. Anybody at the back, if you want to come forward, I don't bite, and I'm happy to have people around. I also have brought some chocolates and some little screen cleaner wipes in the shape of a cat and a dog from the Australian computer security team. So if anybody is participating, asking good questions, I've got some chocolates and small furry toys that I can throw at you. So just to go through an introduction about myself, my name is Jamie Gillespie. I'm a senior security specialist at APNIC in Brisbane, Australia. My role as a security specialist involves me doing community engagement, CERT building or computer emergency response team building, information security, as well as training for law enforcement agencies, doing security awareness, and of course, doing some internal APNIC security to make sure that our own systems are secure. My background working in security, I started about 22 years ago working at the Australian CERT team, AusCERT. I then moved on to Google, working in their Australian office as a security engineer, and then moved to Macquarie Telecom in their cloud services as a cloud security engineer. I've been at APNIC now for about 6 years, actually. I think next month is my 6-year anniversary at APNIC. This is, I think it's the second time I've presented at a ThaiNOG day. I think the last one was probably ThaiNOG Day 1, 5 years ago. So nice to be back. If anybody wants to contact me after or even during the workshop and tutorial today, my email address is very simple and straightforward. More than welcome. If you have any questions after the workshop, you can email me. If you need any advice, happy to help as well. Pretty much the only social media that I use is LinkedIn. I don't really have a Twitter account that I post on. So if you do use LinkedIn and wish to connect with me, I'm happy to do that as well. In general, contacts for the APNIC training team is, again, very straightforward, training@apnic.net. This is the best address as there are multiple people who track this address. We use a ticketing system to ensure that all messages do get replies and that information is followed up. This address is best if you have any feedback about this workshop and tutorial or others, if you have suggestions for future ones, or if you have requests. APNIC does travel around Asia Pacific region quite a lot, delivering all sorts of different training and workshops. Also, because we are talking about security this afternoon, we do have a mailing list as well as sort of a web interface for the mailing list. This is a system that we call Orbit, and it's a mailing list called Security-Discuss. You can subscribe as a mailing list, or you can just access it via the web interface as well. We do post a lot of security news on there, as well as open for people posting their own security related information or having security discussions. Now, we sometimes use Menti, we sometimes use Kahoot in different ways of doing things. I personally like a very free-form and open way of doing it. So what I do for some of my workshops is I actually create a shared document. We don't use Google within APNIC. If it was personal, I would use Google Docs, but we use Microsoft 365. So this is just a Microsoft shared document. This tiny URL will redirect you to it. It's just an anonymous document. You don't have to be logged in to access it. And you can just type in your questions in the lower section. This is if someone's feeling shy, doesn't want to put their hand up and ask a question in person, you can go into this document here and ask your questions anonymously. And then just before the break time, just before the end of the day, I can go in and answer your questions as well. I'll leave the document open for 1 or 2 days after today. So if you think of questions later and you don't want to email me, you can just put them into that document and I can type answers into that document directly. Also, if I have any links that I want to share, I can share those links and resources into that document, and then you can just copy and paste them out of there easily as well. So URL, tinyurl.com/ThaiNOG5 security, and that will redirect you to the Word document. That's just a view of what I'll be seeing on my side with the Word document, and you just go down, go into the questions section and just type in your question, and then I'll do answers as bullet point indents. So for the security tutorial today, I'm taking a slightly different approach. Instead of just having one topic and going through and covering the 2 sessions this afternoon, I actually have 4 different topics that I'm going to be covering and going through and discussing. The first 3 should be approximately 30 to maybe 45 minutes for each one. So that should cover off for the first session, and then we'll have our afternoon coffee break. Then after that, we have a session on vulnerability assessment and penetration testing. This one has some hands-on components. So we actually have an online lab in the APNIC Academy. To access it, you go to academy.apnic.net. It does require a login. So if you wish to follow along and do the hands-on work with us, you will have to create a free account. It's just your email address and password and name. It's a very quick creation process, but it will expose you to the APNIC Academy website and the free labs that we have for hands-on activity. This one's related to a bit more of security side of things, but we also have labs that cover routing technologies, some quite complex with 10 or 12 different routers inside of the fully interactive lab environment. So starting off with things, we're going to look at the first topic that we're going to look at. This is a presentation that I only just recently created. I delivered it at an Australian computer security conference just last week. I delivered it on Thursday, actually, before I flew up here. And the topic for this one is analysis of SMTP email server implementations of TLS for transport security and encryption. Now, this topic is something that I found interesting, and I'm hoping that other people find it interesting. It's something that isn't as commonly seen. It's part of that low infrastructure of the internet where people just expect things to work. For the presentation I did last week, I focused on the Australian environment, but I'm able to reproduce it and then focus on the Thai environment here as well. So hopefully we get some interesting insights. So for this, we're going to look and discuss the importance of SMTP security. We're going to look at different security options. We're going to look at my methodology for doing research into the current state of security. We're going to do an analysis of the TLS implementation security across different systems and groups of systems, and then close off with a recommendation for where people should be going for SMTP TLS security. So when we look at the importance for SMTP security, we have to look at how much of our lives is dependent upon email transportation. As much as we try and do things through secure web portals and logins with strong authentication and 2-factor and everything, we still end up with email being used by many companies and governments for a lot of very sensitive things. If you think about what's in your personal email, but also your work email, Think about the personally identifiable information that is stored in there. This may only be a few email messages, or it could be a lot more. Names, phone numbers, addresses. You may have credit card information. I know sometimes when I travel around the world, if I'm having to book a hotel, sometimes they require me to give a photocopy of my credit card and fill in a Word document form and send it to them by email. So essentially, I'm sending my credit card details over email, sometimes as a picture, sometimes as just text in an email message. There may be health data as well. If you go for medical tests, you may get the results over email, or you may get a link to access the results over email, which essentially means you're getting the results over email as well. We try to avoid this, but many websites store passwords in plain text. And if you say, I forgot my password, they will send you an email with your password. Once that is done, your email now has passwords saved in it, as well as it being transmitted across the internet from one SMTP server to another. Along with passwords is one-time password codes and tokens and login links. Some systems, including Facebook, have been moving to this more passwordless login, where you don't have to remember a password, you don't have to log in the traditional manner. You click a link and it sends you information in your email. And then from there, it provides you access to their system. Those links transferred from one mail server to another, and then eventually ending up in your inbox. Now, this doesn't help when we have blog posts and information on the internet that says things like how to send sensitive information via email. Now, even if they go into the specifics of actually how to do it properly, they are implying it is okay to send sensitive information over email. Email is secure enough to send sensitive information, when in reality, it is not. There's also a user perception of how the average user is accessing their email. Think about a user who is accessing Gmail. Technically, it's mail.google.com, not gmail.com, but you get the idea. When they access their Gmail, they see a lock in the corner. They see high security encrypted access to Gmail, and they think that their email is secure. But as soon as they send an email back to their bank, back to their healthcare provider or hospital, when it leaves the Google servers and it goes to the other servers, we're relying upon a level of security and encryption that is A, very hidden, and B, very broken. There's then the technical visibility. You could have a manager, director, sometimes even a CEO who sees something online, has a discussion, and says, hey, I went to this SSL Labs website, the one run by Qualys. I typed in our website address. Why don't we have an A+ rating on our website? Make our website more secure. So people go and they work on the servers, they improve the TLS security, and then they can say to their boss, hey boss, we now have A+ security. When in reality, it's just for the cryptography side of it for transport, but it's something that is easy to see. It gives you a grade, it gives you a letter, it tells you what needs to be done, and anybody of any technical level can do it. Do we have something as easy as that for mail servers? Not really. And if there is, it's a little bit hidden, a little bit harder to understand, and not as easy to actually make the changes. The other thing is when we talk about SMTP communication from one mail server to another, that is hidden from the users. There's no padlock where the user can type in an email address for their bank and see that from their mail server to the bank's mail server, it is encrypted. There's no padlock, there's no notice, there's no information. Also, we have HTTPS, which is a migration from HTTP to HTTPS. The S stands for secure. It brings up a padlock. We don't have mail to S. We don't have a way that you can do something to an email address to say, I want security. You just have to rely upon whatever the other mail server is using. And it's out of your control. Again, you could be using Gmail with all of the security of Google, but if you send an email to your bank and your bank doesn't have good security, that is going to be the weakest link, and it's completely hidden to the user. So with server-to-server communication, it was decided upon several years ago that instead of using a different port number with dedicated mandatory TLS, similar to HTTPS on 443, instead we're going to keep using port 25. It's going to start unencrypted, plain text, and we will use start TLS to then do an upgrade to encryption. There was a competing standard saying that we're going to use a different port number for TLS. That unfortunately lost out, and this is the way that we're going. It does make sure that email goes through, but it is harder because we're not dealing with a guaranteed encrypted communication. Only if both parties agree will it be upgraded to TLS through Smart or Start TLS. If the server doesn't support it, the communication will fall back and continue as unencrypted plain text email. Would that be ever acceptable in a website? Would you ever go to https yourbank.com and say, oh, if there's problems with encryption, that's okay, just fall back to unencrypted? We would never expect or support that type of activity on web servers. And yet, this is happening every single day on SMTP mail servers. Now, with this unencrypted connection for server to server for email, this is obviously very open for man-in-the-middle attacks. Now, probably two of the most common ways that people could do man-in-the-middle attacks between mail servers is using DNS cache poisoning and BGP hijacking. Here, the DNS cache poisoning is talking about poisoning the cache for an MX record for the destination mail server for the destination domain. So if we're talking about bank.com, it would be looking at the MX records for bank.com for that destination. And BGP hijacking, we've seen cases of BGP hijacking where they've hijacked all sorts of different traffic. There was even a cryptocurrency exchange that their BGP routes were hijacked and all of the traffic was man-in-the-middle attacked. And it actually ended up stealing large amounts of cryptocurrency from their customers because they were able to sit in the middle of the connection and do everything as if they were that end service. And the thing is, if you target your interception and only do it for email, and you're only observing and passing it through, it's quite possible that the person being attacked would not even notice that their mail was being routed through another server before reaching the final destination. So I'm going to go over the most popular SMTP security options here and discuss and look at each one of them. Now, starting off with some of the newer ones that provide the type of protection needed for what I'm talking about. The first one here is called DANE. This stands for DNS-based authentication of named entities. This can be used for other things, but what we're talking about here specifically is SMTP TLS. DANE takes a TLS certificate and associates it with a server. And this is done via DNS. And this means that it can actually do this without the need for a signed, trusted root certificate authority. So this means you can actually use self-signed certificates with the proper level of authentication that, yes, this is the approved self-signed certificate and not one created by an attacker. So this basically gets rid of the PKI infrastructure if you want. You can use a signed certificate if you want though. So what happens here is a fingerprint or a hash of the certificate is taken and stored in a DNS record called a TLSA resource record. Now, the DNS changes come from an authoritative point of view of the organization, and they are saying, yes, expect that the self-signed certificate is going to match this fingerprint or this hash. Now, because the information is being tested against via DNS, this is where DNSSEC comes in very important. We saw Champika just before lunch break talking about DNSSEC. And the reason why is because it is the best way of making sure that the integrity of DNS records has not been tampered with. Now, by having a TLSA record in DNS, this is a signal to start TLS, signal to the SMTP servers that it must use start TLS. It says, our server supports it. We want you to use it. This is the fingerprint for the certificate to expect. And this is the way you should be communicating with us. So if the sending server understands DANE, knows to do a check for the DNS record, it will then make sure that there is no man-in-the-middle attack between one SMTP server to another. Now, as with everything on the internet, there is no one perfect solution. Here we have a second solution for a different way of achieving a similar result. It's called MTA STS, or Mail Transfer Agent Strict Transport Security. This is another way of allowing an email service provider or the destination mail server provider to declare that they support TLS and if they want TLS to be enforced. Now, this allows two ways. This is basically on for enforced, you must use TLS, or testing mode where it's still optional. So obviously, testing mode to begin with, you make sure it's working properly, then you switch it into enforced mode. Now, if the STS sounds familiar, it's probably because HSTS. This is the way that you can do the same strict transport security for your web server. You can use HSTS to signal a web browser saying, you should and must only communicate with my web server using HTTPS and using certain restrictions on TLS. Now, this is different to DANE in a couple of ways. They both use DNS records, but DANE actually publishes the policy on an HTTPS web server in a well-known directory, .well-known. So for DANE, there's a DNS component and an HTTPS component. For MTA STS, we're looking at DNS only. MTA STS requires TLS version 1.2. Dane doesn't specify a version, it just says must use TLS, must use encryption. Whereas MTA STS sets a minimum threshold for the version and the levels of security given with it. And for MTA STS, you must use a signed certificate for TLS. You cannot use a self-signed certificate. So MTA STS still relies upon a root CA with the PKI infrastructure behind it. This, of course, can be free ones such as Let's Encrypt, but it needs to be a signed and in-date certificate. Now, MTA STS uses DNS, so you really should be using DNSSEC for full maximum security, but the standard for MTA STS does not require DNSSEC. So there is the possibility, if you do not use DNSSEC for your domain yet, you can deploy MTA STS, and then once you get DNSSEC, you can then also deploy Dane. And that's the thing. These two standards for Dane and MTA STS do not compete against each other. You can deploy both of them at the same time and gain the level of security if a sending mail server only supports one or the other. Now, another SMTP security option here is using DKIM. This may be one that you've heard of before. It stands for Domain Keys Identified Mail. This is a method for detecting forged or spoofed email addresses. This is done by adding a private key and signing a message when it's being sent. Then the receiving party can use your public key to verify that nothing has been changed along the way and that it actually came from the source it says it came from. These things, the public key is published in a DNS record. So again, you should be using DNSSEC for maximum security, but it's not mandatory. This helps with email spoofing and phishing attacks, but that's a little bit out of scope for this conversation. That's more about from the user to the user. We're talking about server to server. So DKIM is good, but it's a different area of email security. So we're not going to go into any further depth on that one. Similar to DKIM is Sender Policy Framework, or SPF. This is the one that most people would be aware of. Almost every domain I've come across has an SPF record created. This is, again, another standard and mechanism for preventing spoofing and phishing attacks. It works by verifying incoming mail comes from an authoritative mail server for a domain. This is published by a list of authoritative mail servers in a TXT record in DNS. So again, DNSSEC would be something that would be very useful here to ensure that the DNS records are not modified in transit. Again, because this is looking at preventing phishing and spoofing attacks, this is not exactly what we're talking about in this talk. SPF is very good. Everybody should be using it and deploying it, but we're looking at server to server communication. So this is also out of scope. And then there is DMARC. DMARC, not as many people have this deployed. What it does, it's another system for validating, detecting, and preventing of email spoofing. This basically takes DKIM and SPF and extends them a little bit further in how they check the from address, how you handle failures, and how you handle reporting if an email message is broken and not passing these checks. So DMARC is something that you're going to deploy after you have SPF and DKIM up and running. It's another way of helping prevent spoofing and phishing attacks. So again, this is a bit out of scope for this presentation. So we're not talking today about SPF, DMARC, and DKIM. We're talking about server to server. So for this analysis of TLS implementations, I actually went through and assessed many different mail servers. For this presentation today, I targeted the ones that are based in Thailand, as well as a few global mail servers as well. To do this, I wrote some very bad Python code that works enough, that takes in a list of domain names, queries to find all the MX records, queries DNS for those MX records to see if any of them have MTA STS, get the actual policy off the web server, compare the MX records against the policy to see if they all match, querying DNS for the TLSA resource records, for DMARC records, for SPF records, and recursively going through all the SPF records as well. Then I write it out to a series of files, and I do analysis through a series of different things. One of the tools that I'm using to look at the TLS security is I'm using a tool called testssl.sh. That's the name of the tool. It's also the name of the website. This checks against the mail servers as the MX records, looking at the TLS cipher suites and common vulnerabilities. This is very similar to the Qualys SSL Labs website that you use for assessing a web server security. I'm using test SSL because it allowed for outputting to CSV and JSON files, which made it easier for me to do analysis against a large list of different mail servers together. There's a competing tool called SSL Scan. It's very good. It's a little bit faster, but it didn't provide me with the output options I wanted. So if anything turned up weird from test SSL, I validated the result using SSL Scan. After all this, I then did some very manual analysis, grep, Excel, and even using a custom Python script to look for differences and similarities across similar mail servers. So once I created all the tools, I created lists of companies. These allowed me to then group them and then do analysis and review them across there. Not just looking at companies and their website domains, but I needed to see if any of their email domains was different to the website domain. This is common for some companies where they want email to go in a different way, or they maybe have a more global email address domain to use. So a lot of websites will have their privacy policies advertised. So I was going to these websites, digging into their contact details and privacy policies, looking for the actual email address domain to use. For this presentation today, the groups that I created, there was one for the Set 50. So this is the top 50 companies on the stock exchange for Thailand. So very large publicly traded organizations. I looked at some Thai government ministries, some of the larger government departments, some of the top Thai ISPs. What the internet said was the top Thai universities. I don't give any preference to what the university rankings are. And for a comparison, I also looked at some of the top international email providers like yahoo.com, Gmail, even AOL.com. Yes, they still exist. So breaking this down, looking at the Set 50. So I ended up with 49 domains. There was a little bit of duplication that needed to be removed, where there was one parent company that actually had two child companies listed on the stock exchange. More than half of them were using hosted mail providers, such as Outlook.com, PP Hosted, and Trend Micro. One domain had 11 MX records across 3 different providers, which doesn't make a lot of sense because each one would handle the email a little bit differently. Some of those email providers actually were no longer valid, believe it or not. So a lot of these ended up as dead or duplicated mail server records. They also had 2 duplicate SPF records for Outlook.com. So they weren't exactly doing a proper review of the security and configuration for their mail servers. Of these 49 domains that I looked at, only 1 domain was missing an SPF record. This is how good SPF is being deployed. Almost everybody has an SPF record, but that's only helping with spoofed and phished email addresses being sent out. This is not helping with server-to-server encrypted communication. The SPF policies were an even split between having fail policies and soft fail. For DMARC, 21 of the domains, so about half of them, had no DMARC policy at all. Of the ones that had DMARC policies, 14 of them had their policy set to none. This basically means the DMARC policy is ignored completely. So if you take 21 and 14, you end up with 35. So out of 49 of the largest companies in Thailand, 35 of them do not have DMARC records. 5 of the domains have a DMARC policy set to quarantine, which is a good start. Although one of them had their subdomain policy set to none. So you could have bank.com that has a quarantine policy, but my.bank.com, that policy would be set to none because it's a subdomain and completely ignored. So still open for abuse by phishing and email spoofers. And at the high end of doing things properly, 7 domains had a policy that was set to reject, which is the way that it should be for a fully created one. One domain that had a DMARC policy had no reporting email address associated. All the others had email reporting set up, which means if there's any failures for DMARC, they're going to get email reports, and that's the way it should be. Mind you, this one that's missing an email reporting address had the policy set to none. So yeah, not very useful to begin with. Now let's look at MTA, STS, and DANE. Of the set 50, the 49 domains, no domains had MTA, STS, no domains had TLSA records for DANE. That means none of these domains have a requirement for encryption from one mail server to another. 3 domains had mail servers that were using expired TLS certificates. And one of those 3 expired certificate domains actually was using a self-signed certificate. And a self-signed certificate without DANE is not a very good configuration. So let's move from the big companies to the government ministries. I found a list of 20 of the larger federal ministries within Thailand, things such as the Ministry of the Interior, Foreign Affairs, Defense, Finance, Education, Justice, and similar large ministries. Now, when we compare these 20 ministries against the set 50 domains that I looked at, it's the same mix of self-hosted mail servers and externally hosted mail servers. So not a lot of a difference there. 4 domains for 4 ministries had mail servers split across 2 different mail providers. Again, the backup mail servers were not providing a consistent mail routing. Looking at SPF and DMARC, there was 100% of deployment of SPF and a split between fail and soft fail policies. So what we expect to see. For DMARC, out of the 20 domains, 14 had no DMARC policy at all. 3 had a DMARC policy set to none, basically disabling the DMARC policy completely. Only 1 had a policy set to quarantine, and only 2 had a policy set to reject. So really only 3 out of the 20 were using DMARC properly. All the domains with a DMARC policy were using reporting email addresses, another sign that they're doing things correctly. None of these domains had MTA STS configured, and none of these domains had DANE configured. So let's move away from the federal ministries that can maybe have some problems with, government bureaucracy, and let's look at some of the top Thai internet service providers, the technical companies that help the internet keep running. So I looked at 17 domains, was looking at the top 20, but a few internet providers were parents and children of each other, so I deduplicated those. Most of these ISPs are running their own mail servers, so that's not a really big surprise. And a few of them are using Outlook.com as their outsourced mail hosting. SPF was deployed for all 17 domains, slightly more soft fail than fail, but all roughly configured well for SPF. 2 domains were using self-signed certificates for their email servers. For DMARC, more than half of them had no DMARC policy at all. 4 of them had a DMARC policy set to none, basically disabling it. 1 domain had a DMARC policy set to quarantine, but had a subdomain policy set to none. And 2 domains had a DMARC policy set to reject, which is the strongest configuration, but one of them had a subdomain policy set to none, basically disabling DMARC security if the attacker chose to use a subdomain in their email address. So instead of isp.com, they could do my.isp.com and go straight through DMARC security. Still, not a single one of these domains had MTA STS configured, and not a single one of these domains had TLSA configured for DANE. So let's look at some universities. Top 20 universities, most were using external hosted mail servers such as Google and Outlook.com. And you'd think if they're using an external hosted mail server, they would support some additional security, but people just aren't turning them on. 3 domains had mail servers across 2 providers, some of which were dead, old, and just not responding to mail requests at all. 3 domains are using mail servers that do not support Start TLS at all. There is no option for encrypted email communication with 3 of these universities. It all must fail back to unencrypted plain text. Now, all the domains that do support TLS were using valid certificates, which is a good thing. SPF turned on for all the domains, as you'd expect. DMARC, there were 7 of the domains with no policy at all. 5 that had policies had them set to none. So of that, you were looking at 12 out of 20 that basically don't use DMARC at all. 8 had DMARC policies set to quarantine, which is a good start. None of them had DMARC policies set to reject. All but 1 that were using DMARC policies were using email for reporting, which is a good sign that it's configured well. And believe it or not, still 0 domains had MTA STS configured, and 0 domains had TLSA Dane configured. So let's look at the international email providers. These are the companies whose pretty much only job is to do email and do it well. So these are some examples of them just to show the types of companies and the spread that I'm looking at here, including some that are Russian, some that are US, some that are European based. All of these are using their own mail servers, which really isn't a surprise when that's their business. Only one domain was missing an SPF record, good to see. But two domains that had SPF records were using the $all policy, which is basically the same as not having SPF at all. So in reality, there's 3 domains out of these that are not using SPF. For DMARC, only 2 domains had no DMARC policy. 7 of them had their policy set to none. Some of these could relate to them not using these domains for outgoing business email. For example, for Google's Gmail, Gmail had a policy set to none, whereas google.com had a policy set to reject. So a lot stricter for their corporate communication and not as strict for the general user-to-user email. 3 domains had a policy set to quarantine and 5 had a policy set to reject by default. Now, this is where we're actually seeing TLS security deployed properly. 8 of these domains had MTA STS configured. So finally, some people are using MTA STS. 4 domains also had TLSA records, meaning that they're configuring Dane to have TLS security in a different fashion as well. Now, if we look at the Thai servers and we look at some of the weird discrepancies that are happening, we had one government domain that was still using 40-bit export grade cipher suites. So for any of you in the audience here that has been doing internet and internet encryption for more than 20 years, you'll remember that the United States used to have a limit on high-level encryption and that you could not use strong encryption outside of the United States. This is the 40-bit export grade encryption. When we talk about 128-bit and 256-bit encryption, this is a very limited, weaker form of encryption. It was basically stopped 23, 24 years ago. We also had one set50 domain and one government domain that was using cipher suites that were anonymous cipher suites, basically saying that there's going to be no checks against who is doing the encryption, but just that the encryption is being done. So something that absolutely could be injected as man in the middle, and the TLS could be broken by forcing it to be anonymous, re-encrypted. Now, if we look at SSL version 3, this is a version that was deprecated about 8 years ago. There was one self-hosted ISP still using SSL version 3, one self-hosted government domain still using it, as well as being enabled for some of the more hosting domains such as BNets, Message Labs, and PP hosted. So some of these are professional mail hosting companies, and they still have SSL version 3 enabled. If you had a website with SSL version 3 enabled, you would be getting pretty much a fail score on the SSL Labs website. But for email, SSL version 3 is perfectly fine. It's accepted. If we look at TLS version 1, which was deprecated several years ago as well, it's still enabled for many big email providers. Many of them are being used by set 50 domains. Large providers such as FireEye, Google, Message Labs, PP Hosted, and Trend Micro are still using a deprecated version of TLS. And many of the self-hosted government domains and a few self-hosted ISPs as well. There's a couple of domains like Mimecast and Outlook that only allow SSL version 1.2, which is a currently accepted and mostly secure version of TLS. There's a few that support TLS version 1.3 as well, which is the latest secure version of TLS. Google, Mimecast, Trend Micro, and most of the top international email hosting providers are allowing and using version 1.3. 1.3 was best supported by several of the set 50 companies, mostly thanks to them using Google and Trend Micro. A few government ministries, 3 ISPs, and even 1 self-hosted university. So thumbs up to that self-hosted university for using the higher end of encryption. But it is quite interesting that Outlook, PP Hosted, Barracuda, FireEye, and IPHMX are not supporting 1.3 yet. There's no cost to turning on and supporting the newest version of TLS. In fact, many of their websites do support version 1.3. So why do their mail servers not support it yet? So recommendations, what do I want you to do, especially as the internet community, primarily from Thailand? I want you to get out there and test your own servers. I want you to also test your critical vendors and partners. Because remember, if your server is secure, you still have to send email to other domains and other mail servers. So if you're ever sending sensitive email to a trusted partner or a trusted vendor, you should be testing their mail server as well. And if it is not doing good security, you need, as a customer, to put pressure on that vendor, on that partner, and say, hey, your mail server is not doing adequate email encryption. They probably don't even know. So the tools that I was talking about, test SSH or test SSL.sh and SSL scan. These are easy to download off of GitLab. They might even have packages for a Linux distribution that you use. You can just do a simple apt install for them. There's also a couple websites that you can use. These aren't perfect. They don't give you an easy score. You sort of have to drill into the information a bit. But if you don't have a Linux machine handy and you want to do it in a web browser, you can use internet.nl and aucheck.com.au. Both of them do very similar sorts of checks. Internet.nl has been running for a bit longer. Very easy, no account creation, no verification. Go there, type in an email domain name, and it will do the checks for you in about 1 to 2 minutes. You can also check DNS signing for your own domain and any other domain that you're using to see if DNS integrity is being protected. Again, this is part of what Champika was talking about from ICANN and their kindness or kind DNS program. So on Linux, installed mostly by default, easy to find if you need it, is the program called Delve. This lets you look for DNS sec verified or validated domains. Simple command delve.apnic.net will return either fully validated or unsigned answer for whether it's DNS signed or not. You can also use dig. Everyone has dig around. Just do a plus DNSSEC, and you're looking for flags AD. That stands for authentic data. And you're looking for an eDNS flag of do or DO. This stands for DNSSEC OK. So you're looking for AD and do. And if you're on Windows, there's PowerShell commands that you can use as well, resolving DNS name with DNSSEC OK as an additional flag. Because remember, if you're using systems that rely upon DNS, you need to make sure your DNS is secure as well. So more recommendations: SPF, DMARC, DKIM. These are great, and most people are getting them deployed already. Still a bit of work to do on the DMARC side of things. They're great for stopping impersonation, great for stopping spoofed email, but they do nothing for making sure that your email coming in is actually encrypted from one server to another. You should be setting up DANE if you have DNSSEC set up already. Once you have DNSSEC, setting up DANE is easy. If you don't have DNSSEC signing for your domain name yet, set up MTA STS. It does not require DNSSEC. And if you don't have DNSSEC, you should be setting it up anyways because it's an important thing to do. Refer back to Champika's presentation earlier. And way back at the beginning, when I talked about BGP hijacking as a way of doing man-in-the-middle attacks, we have a tool for fixing that up as well. RPKI is a system that has a sole purpose of protecting BGP routing information. It's a little more complicated to set up and make sure it's working properly, but once you protect against BGP hijacking, you protect every application that goes across the internet at that point in time. Cool. So, do we have any questions relating to SMTP, mail server to mail server encryption and security, or any of the analysis of data that I've been collecting here? Yes, now you might have to come up here for microphones. We do have virtual attendees, so I want to be good in letting them through.
Thank you. So couple of questions. One is about the ethical implications of doing this kind of analysis. I mean, usually when we do a study like this for IMC or the security conferences, we have to run this through an ethical board. And sometimes it takes a year to get approved and partly. So within APNIC and with this analysis that you do regularly, I mean, how is that? And the second question is, considering your threat model, if there is a BGP hijack attack and then you're doing this man-in-the-middle attack against SMTP, server-to-server communication, then you'll be stealing email, stealing messages that are being sent at that time, right? So my question is, how long it would take for this attack to be detected, and kind of in the worst case scenario, how much would leak from this attack? So kind of what would be the dimensions and how likely this would be quickly detected or not? Because I think it would. No?
No, very good questions. I'll throw some chocolate your way in a second. So first question, talking about the ethics of the information collection. At this moment, APNIC does not have an ethics review board, so I guess we're a little bit lucky in that way, lucky slash not so lucky, but so I basically impose my own best practice or my own application of ethics for the way that I was collecting and presenting the information. So the information that you can see me presenting, I'm not calling out specific internet providers, government ministries, set 50 companies and saying, hey, this company's not doing it right. I'm grouping it together. I'm giving the statistics for applications of security and that. Anybody can do and repeat the assessments I did to find what the information is. Anybody can go and assess their own servers and information. Nobody has created a Qualys SSL labs for this specific purpose, but you could. In the same way that SSL labs was created looking at port 443, you can create one that looks just at port 25, put all the results up on a website, and look at the same as SSL labs. In fact, Qualys could modify their website and allow scanning for services that are not using native SSL and are not using port 443. But they don't do that on the SSL Labs website. But tomorrow they could release a new version to do the same thing. So we're not looking deep into the server. We're doing the same scan as you would for TLS cipher suites and versions that are done on websites. And I'm not actually sending any email messages through these servers. So I'm only doing the initial connections, looking at the start TLS command. No actual email messages are being sent for testing purposes or anything. There was a small number of Thai mail servers that actually did not like me running these tools against them. And they basically went, too many connections, you're blocked for an hour or something like that, which for a regular mail server, perfectly fine. Mail will retry and carry on. So yeah, so I saw that and thought that was interesting. I didn't actually run across any Australian mail servers that would throw up a timeout or a connection blocked message for those sorts of things. But I can understand these tools are making repeated TLS connections, but they do them serially. So there's no repetitive parallel smashing of server all at the same time. I also did assessments, I didn't mention in here, on mail servers that were configured identically. So for Outlook.com, for example, every server that ends in Outlook.com that's hosted by Microsoft has 99% identical configurations. So there's no point in me reassessing every single Outlook server. Once I see that someone's using an Outlook server in a group, I deduplicated them down to just one or two just to do a double check. So for some of these, I'm not hammering these hosting companies again and again and again. I'm doing it as gentle as I can to make sure that the impact is not there. But it's just one host doing one scan. For a server, one mail server, it took maybe 30 seconds or something in amongst all the global traffic that's going against these servers. So yeah, so I'm doing my best to be ethical in my collection and reporting of this information. And if anybody works for any of these networks or companies that are grouped loosely up in here, I'm happy to discuss with you. Also, in my copious amounts of free time after this, I will be going back and sending some messages to the companies where I found this data. I only just released this last week and this week, so I haven't had the time to do the follow-ups, but I will be notifying these companies and saying, hey, this is the information I found. I don't really care if you reply to me or not, but just sending it out so that they at least are notified, hey, somebody is paying attention to this, and these are the current recommendations for best practice security to make sure that you're actually doing encrypted email rather than unencrypted. Yes, sorry.
I'll add a sub-question to that. When you're performing the measurements, have you yourself followed the best practices for internet measurements, internet web measurements? You know, if you go to GitHub or like the University of Stanford Internet Measurement Research Group, you'll find that, and also IMC 2013 paper, I think, there's a list of best practices when you do scanning and like limiting packet rate and using randomizing the address space and that kind of thing. So kind of that's a question. Have you followed that, like a reverse DNS entry, and so people can find you? Who is scanning me?
I didn't look up that best practice, but I was doing it from an APNIC address that did have resolution back to APNIC. So I was not doing this from a home network or some random VPN provider. So it is authentic back or authenticated back to APNIC in one way or another. And if people don't know how to contact APNIC, we've got bigger problems. I was also following the general multi-religious principles of I was doing to others what I would want them to do to me. So I was doing things in a speed and serial nature that I would want others to do if they were scanning my own mail server that I was running. And, having worked for large and small companies before, I'm understanding that not everybody runs the largest mail servers in the world. So I'm taking that into account. So what was your second question? I went way too long on the first question. Oh, the man in the middle, yes. So if you do a BGP hijacking, you are going to take the entire route, which means you're going to take the entire traffic across. If we assume that the BGP hijacking is done by a malicious attacker that has enough bandwidth to take your entire connection, or at least from that region of the internet, the traffic will be routed through, and then they can do whatever they want. If they do nothing, it'll come in and then spit back out again if they push it back out. If they run a mail server on the IP address as your mail server, if they run the mail server and a DNS server, they could actually authenticate as the domain owner. And they could do a whole bunch of things. This is what happened with the cryptocurrency exchange BGP hijacking. They actually said, oh yeah, I'm also that DNS server. Here's my domain verification. Oh, you want website verification? Here's my website. And because I did domain verification, I can now get a signed SSL certificate as that company, and I can put things on the website. So BGP hijacking breaks TLS encryption, breaks root certificate signed certificates, breaks a whole bunch of security layers where we're depending upon email and DNS being authoritatively run by the company that they're purporting to be from. For SMTP attacks, the most likely scenario would be that they would be running, the attacker running an SMTP server. The mail comes in, they do whatever they want, take a copy, make a change, anything like that, and then the mail spits out again. That mail server could be configured not to add an SMTP header, but most likely the next hop to mail server would record where it was coming from. But again, they've hijacked the routes. They would have the IP addresses, and they would then, the next hop, see the connection coming from the IP address of the legitimate company. So if done properly, it would be very hard to detect. Now, detect from the actual traffic side of things. From a routing perspective, there are tools that are looking for hijacks and being announced from places that they shouldn't be. There's been proposals and policy discussion on whether the internet registries, such as APNIC, should be proactively looking for hijacks and giving warnings and punishment to domains that are repeatedly hijacking. Now, BGP hijacking can be done by accident and can be done intentionally, and it's hard to determine which one is being done. But there is discussions around that space of detecting, notifying, and punishing networks that do BGP hijacking. But if done well, it would only be noticed by the routing nerds. It would not be noticed by the actual content traffic, which is scary. Yes.
I want to ask if you have done any comprehensive testing with the Google Mail server, because most university in Thailand here they use Google Workspace because it's free, so they're hosting all the mail server at the Google. Do you have any notice some security?
Yeah, so a lot of the assessments that I did were for Outlook.com and Google.com mail servers. They're all configured good, but they do have some backwards TLS capabilities. You know, having worked for Google myself, I know that there would be assessments being done and looking at who is still using TLS 1.0 and that balance of allowing the email to be encrypted with something better than nothing. They also are better at their cipher suite selection. So if they're doing encryption, they're allowing you to do good encryption rather than 40-bit encryption or anonymous encryption, which is completely broken that we see on some of them. So there is some of that uplift. So they are providing it. But the thing is that the mail server is not the only component here. So if a university or if a private company is using Google as their mail server, as their hosted email, that university or that private company still has to configure MTA STS or DANE to say, we only want encrypted email. You must use encrypted email with us. And then they have to make sure that Google supports encrypted email, which obviously they do. It's set by the domain owner. So it's not set by Google. So yeah, so take for example, you have a university that runs their own DNS servers, but uses Google for email, uses Google for the MX and the mail servers and that. The university has control over their DNS and they need to configure DANE and or MTA STS in their DNS server to say, when you talk to the Google mail server, you must use TLS security. So it's not something in the Google console or the Microsoft 365 console where you can flick a switch and turn it on. It has to be done using the DNS of the domain that you want protected. So yeah, so obviously Google and all the others support the higher levels and good encryption. So that's step one. Step two is MTA STS and or DANE, which needs to be configured in the DNS records by the domain that would be at email at domain, whatever. Yeah. So it's that extra step. And this is probably where it's been a bit harder. Some other things, you know, like say DNSSEC. If you are running a hosted DNS service, you know, a company that manages DNS for you, there sometimes is just a little switch. Just flick a little thing over to the side, tick a box, and boom, you have DNSSEC. And they manage it properly, which is great because DNSSEC is not easy. As with anything with encryption, you want to make sure you do it properly or you're going to shoot yourself in the foot and you're going to block communication because good encryption is secure, bad encryption is just as secure and preventing you from accessing it. It's like if you have full disk encryption on your laptop and you lose the key, your laptop data is garbage now because it's so properly encrypted. So DNSSEC is hard, but a DNS hosting provider has a little tick box for you to turn it on. We don't have that for MTA STS or DANE. It's a little bit more manual, requires a little bit more effort. Any other questions? Do we have people on Zoom? Is there any questions over Zoom? I don't want to ignore the people who might be online, so. No? Excellent. As I said, if you think of any other questions, or if you're a little shy and you don't want to talk out loud, you can put it into the Word document. It's anonymous, and then we can answer those questions a bit later as well. Yeah, sure. Excellent. At least I wasn't aiming for your head. Okay, so yes.
DNS 624. So then what impact it can bring to the DNS security?
That's a good question. I haven't actually looked at DNSSEC for 624. I'll have to look into that one. I'm assuming it supports it and everything because it's just the way that the records are being done. But yeah, that's an interesting point. I'll have to look into that. Thank you for that, Imtiaz. But yeah, I'm assuming that DNSSEC supports it. It's just a matter of where does the signing come to and from. But yeah, if the records are coming from a domain, it would just be a matter of that domain. If they have DNSSEC signing turned on, it would get sent all the way through. But yeah, it would be the matter of who does the change on the DNS record. So. Yep.
Quad A record. So then maybe it's broken or something like
yeah,
that.
I'll have to have a look into that. That's an interesting one to see. So throw it into the Word document, and I'll remember to have a look into that.
Okay.
But yeah, I'm not sure on how that would be impacted. Unfortunately, we don't have Champika here in person. Otherwise, he would be probably one of the best people to ask about that. So.
Okay, thank you.
Thank you. Excellent, thank you. Okay, so we've got about 15 minutes before the afternoon coffee break. I'm speaking straight after, I'm continuing through. So I'm going to start the next presentation and throw something at me when it's time for coffee. and we'll go for coffee break in the middle, and then we'll pick up where we left off. So the next presentation is looking at DDoS attack prevention. So this is looking at an overview of all aspects of denial of service attacks. So we're going to look at definitions. What is a DOS? What is a DDoS attack? We're going to look at some threats and trends of DDoS attacks. We're going to look at how a DDoS attack actually works, some of those high-end ones. Not just looking at how DDoS attacks work, but we're going to look at reflection and amplification specifically. We're then going to look at some mitigation strategies for inbound DDoS as well as outbound DDoS. So starting at the very beginning. In general, a denial of service attack is an attack against the availability of a service. And for any of you that have studied information security in any way, you'll know that there's the security triad, which is confidentiality, integrity, and availability. They're the three main tenets of security that we are concerned about. Availability is, of course, understood very well by network and system engineers, but it is an aspect of security. Now, this availability could be the availability of an entire network or just a single service, and the whole network is fine. If we talk about plain denial of service or DOS attack, usually it comes from just one source, and it can be caused by exhaustion of resources or exploitation of a vulnerability. If you go back, there's references, back when I started doing networking and security, there was the ping of death, where you could send a specially crafted ICMP packet and it would actually cause some machines to crash and reboot or hang, which is a really exciting thing. There are vulnerabilities in operating systems and vulnerabilities in services over the years that allowed for a single packet to cause a denial of service in different ways. But it could also be resource exhaustion. If you have one end, if you have the attacker who has more resources, more bandwidth, or a faster computer, attacking a weaker destination, it's easy for them to overwhelm it. Now, that's the way things started back before botnets and massive DDoS attacks. DDoS stands for distributed denial of service. This is where the attack is originating from multiple sources. Multiple sources could be everybody in this room going to one website at the same time and overwhelming that one website. I've had that happen. I've put up a website address on the screen, everybody goes there, and the server crashes. It could also be virus-infected computers that are all under the control of one malicious attacker who instructs the virus-infected computers to all do a certain action, causing hundreds or thousands or hundreds of thousands of computers all doing the same activity at the same time. DDoS attacks are focused on resource exhaustion. That resource could be end resources on a server, such as the CPU or memory, but it could also be bandwidth or connection resources that could be impacting an entire network. Now, from a user's perspective, a DDoS attack is going to look like an outage. The service or network is going to be completely unavailable. The security team is going to go to that confidentiality, integrity, availability and say, hey, this is a loss of availability. This is a key part of security. And if it's relating back to business, management is going to see a DDoS as an impact on the financial aspects of the business, especially as the business is earning money using their internet connections or resources. Think of, obviously, internet service providers, credit card and payment gateways, online casinos, and gambling. So from that business perspective, what is the cost per hour or even per minute of the network or service being unavailable? And this is sometimes an easy way to look at what money would be available from the business to mitigate denial of service attacks. So DDoS traffic can be grouped into a few different categories. Down at the bottom, we already discussed targeted exploitation, where you attack a weakness or vulnerability to cause the service to crash or be unavailable. Bandwidth exhaustion is looking at, plain and simple, taking up more bandwidth than is available for the network that you're attacking, whether it be the network of the final hop, the final service that's being accessed. Maybe it's only on a 100 megabit connection, or the network in the middle, where you could be attacking many servers on the network with the goal of filling up the upstream network bandwidth. But we also have connection exhaustion. Sometimes this is done on a network layer, but it's very commonly done against the final destination server. Take a web server, for example. Every time you make a request for a web page or an image or a download file, you're making a connection through both the service and the operating system. And as long as that connection is open, nobody else can use that connection. That's why a lot of services will try and shut down connections quickly as soon as you're done. And if you need another one, you have to restart and open up a new connection rather than holding open a long-lived connection. Now, if you have many people that are requesting connections from a server at the same time and purposefully holding it open, say, for example, requesting a download of a file, but then very slowly sending acknowledgements back. The transfer rate is going to be very, very slow, using a very small amount of bandwidth, but it's going to hold on to that connection and keep it open as long as possible. If a web server can only support 100 concurrent users, once you hit that 100, 101 is going to get an error. They're not going to get a connection, or they're going to get some other error message. Now, when we look at different types of denial of service, one way is to look at it by going through the layers. Now, personally, I'm more of a TCP/IP layer model person, so I ignore the far left. But if we look at the layers, starting from the bottom here, we can look at the protocols and services that operate at those layers. So at the bottom, we have the network access layer. This is where Wi-Fi, Ethernet, copper, and fiber happens. For Wi-Fi, there's DOF and jamming attacks that can take place. When we're looking at Ethernet and copper cables, electrical interference is a thing. This is why a lot of cabling has shielding around it, especially when you run by fluorescent lights that have the ballasts that operate at high frequencies. If you run a cable too close that is not shielded, it can get a lot of interference from it. And of course, don't forget about construction equipment. Construction equipment digging up fiber and other cables out of the ground is a denial of service. So let's move up one layer. So we're looking at IP floods. It's a thing. It's not very popular. It's not very effective, but it used to be. As well as IP fragmentation attacks, another way of really overloading a system by doing weird fragmentation and overlapping. What are you pointing? Oh, I didn't see that pop up. Yeah, I'm still on VPN at the moment, so it's going to be resetting. If we go up a layer here, we're looking at the transport layer. This is where the interesting stuff starts to happen with TCP and UDP. But really, when it comes to denial of service attacks, the only real popular attack here is a SYN flood. We're not looking at the higher layer protocols. We're just looking at the TCP side of things. Now, a lot of attacks use UDP, but they're actually using application layer protocols. So let's get up to the application layer. This is where the good stuff, and by good, I mean bad, the good stuff actually happens. This is where HTTP, FTP, NTP, even DNS is operating. This is where reflection and amplification attacks happen, where you can bounce your attack off an innocent server who then is sending traffic to the victim. This is where amplification happens, using UDP, but using protocols that depend upon UDP. DNS, NTP, SSDP, these all use UDP and are open for abuse for reflection and amplification. But also at these application layers, this is where protocols and attacks such as slow LoRa's, SIP or VIP floods, and even doing complex database queries through a web server interface can happen. The complex DB queries, for example, if you could do a query for a website to tell it to do a search, looking for some complex thing that requires it to go through its database completely, if you can hit it with changes to that search query again and again and again, it's not going to have the results cached. It's going to have to go back to the database every single time, going through the whole database, looking for what it is that you're asking for again and again and again. The web server could be fine, but the database behind it could be completely overloaded with all of these complex and dummy queries. Slow LoRa's is interesting ones. There's a whole suite that I was talking about before where it makes a connection and holds onto it and slows it down and keeps that connection open. Three more minutes? Yeah, cool. So looking at trends and how things have changed over the time, you know, the DDoS attacks have changed and grown over years. Connection exhaustion attacks are hard to track and report on when they come from many different sources and they're reflected off of other servers. But bandwidth attacks are the ones that are a lot more commonly reported. So we'll start down at the bottom. We'll start at some small attacks. So we're looking at maybe 10, 11 years ago. Some of the largest attacks at the time were 60 gigabits per second. Now, 60 gigabits is still a lot. That could take some countries off the internet, let alone large companies. About a year later, not even a year later, 5 times growth. The largest attack seen was 300 gigabits per second. Year later, it jumped up to 500 gigabits per second. Couple years later, it more than doubled to 1.2 terabits per second. This is sustained traffic as well, by the way. That attack was against dynamic DNS or DIN DNS, taking the DNS servers offline, which means anybody who was using that as their only name servers, their websites were completely offline. So by attacking one part of infrastructure, it actually had a very widespread impact across the entire internet. Then a small incremental growth, 1.3 terabits per second against GitHub, then 1.7 terabits per second. And just a few years ago, we had a 2.3 terabit per second attack against AWS. Now, there have been other attacks since then, but they're measured more in connections per second, as opposed to just plain bandwidth bitrate. So it's a bit harder to relate one to the other. So I'm just sticking with simple volumetric types of attacks. 2.3 terabits per second is a scary amount of data for anybody, even the large cloud DDoS scrubbing centers. That said, most reports are showing that the average DDoS attack is only between 1 to 25 gigabits per second, and they typically last less than 4 hours. That's still long enough to really annoy a lot of companies. And some of these are actually DDoS for the purpose of extortion. They'll do a DDoS attack and say, hey, pay us money and we'll stop the DDoS. So that's what a lot of these smaller DDoSs actually are. Okay. I'm going to stop it here so that we can enjoy our afternoon coffee and snacks. If you have any questions, think of them to say over the microphone or put them into the shared document. I'll put that back up on the screen in a second, and I'll see you back here in 15 minutes. I'll see you back here in 15 minutes, and then we've got another hour and a half for the remaining security sessions. Thank you, everyone, for your attention.